Hello everyone, welcome to my channel Hypermesh Basic to Advanced. So to have a bit of a background about my channel, I make videos related to FEA and Hypermesh. So if you are new to this channel and interested in these topics, consider subscribing to get regular updates. And if you are already watching but are not subscribed, kindly consider subscribing as this motivates me to make more videos, right? Okay, so coming on to today's topic. So today we are going to perform a dynamic analysis using Radioss. So this is going to be a bit different from other dynamic analysis. As in this tutorial, we are going to simulate a soft object crashing into a very hard object, right? So the question arises, where is this type of analysis used, right? So this type of analysis is used in aero industry, okay? For example, uh, if you want to simulate an aircraft which is flying in the air and it collides with a softer obstacle, right? So the softer obstacle can be like a bird, right? So suppose the aircraft is flying in the air and a bird comes in its path and it collides with it. So what will be the effect on the aircraft? So to analyze that, we perform this dynamic analysis. So this is going to be a bit different as I told in the starting. So in this, as you can see on my screen, so I have a green surface here, right? So this is going to represent the surface of the aircraft where it is going to collide, the bird is going to collide. And then this blue component is going to represent the bird, right? So what is going to be different is, if you can see on my screen, I have meshed this green surface using regular quad elements, 2D elements, right? But the bird which I have meshed using SPH elements. If I can just show you, I'll switch on this line view and if I zoom in, you can see it's written SPHCL, right? So these are SPH elements. So what are SPH elements? So basically SPH stands for Smooth Particle Hydrodynamics. So basically what happens in this, these elements when they go and collide with something harder, they dissociate into dissociate, right? So this is very similar to what happens when a bird goes and collides into an airplane, right? If you would have seen in movies or if you would have seen any videos, you would have noticed that it basically looks like if the bird has collided and it has shattered in the air, right? So this phenomena is going to be very similar to that, right? Okay. So as you can see my screen, I've already meshed the model. So for this surface, I've used 2D quad element. So if you want to know how to mesh this, you can just go to 2D. You can go to auto mesh or you can use rule, whichever you want. You can go to auto mesh and you can then select the surface which you want to use. So I have switched off the surface. I can just go and yeah. So then I can select this surface and then you can give the element size and the type of element and you can just click on mesh and it will mesh it. Okay. But as for the SPH element, for that we need to go to 1D, right? So here is the 1D, we need to go to 1D, then here the SPH option. Then we can go to SPH and then we have to select the surface which we want to mesh with the SPH element. So we'll just select the surface here, right? And then we have to give the pitch and the density, right? So I have used the pitch as 2 and density as 1 into 10 to the power minus 9. You can try it out with some other material density, but just keep in mind that it should be less dense than this surface, right? Okay, so basically this is how you mesh the aircraft surface and the bird, right? Okay, so one more thing, just in case if you can't view the SPH option here, okay, uh, you can just go to this icon which represents a person or human and you can just click in and then you can select Radioss from here. Then this option will be visible. Okay, fine. So Basically, we have meshed the model. Okay, then what is next? Then next we need to create the property and material, right? As in any other analysis, create the property and material for the component. So I've already created the property. You can see here, there's a property here, right? So one more thing, basically here I am in the solver browser, right? We have a model browser, we have a solver browser here. So I'm in the solver browser. So if you want to see the solver browser, you can basically go to view, and then you can go to toolbars and Hypermesh, and then you can select the solver browser, right? Oh, sorry. You can go to the browser, and then you can go to Hypermesh, and then you can select the solver browser, right? If it's not visible, okay, then it will be visible, and you can just follow on here, right? So I have already created the property, right? So if I just open it, so you see I've created the property for the glass. So what is this glass? So this glass will basically represent the windshield of the aircraft. Okay, so we'll see what happens if a bird traveling at high speed comes and collides with the windshield of the aircraft. What stress it creates on the windshield of the aircraft. Okay, so these are the values which I've used for the property of the windshield, right? And if you want to see the properties, the values in detail, you can just visit my blog post, the link to which I'll give in the description and in the pinned comments as well, right? You can just go there and you can just see the values and copy it, right? Fine. So if you notice here, I've created only one property, right? Only one property, and that too only for the glass. There's no property created for the bird, right? So this is because what happens is when we create SPH element, a property automatically gets created for the SPH element, right? So if I just show you here under the part, so we have the bird surface, right? This blue color one. If I click on it, you see in the property field there is already one property created SPH1, whereas there's no property here, right? There's only glass property here. So it automatically gets created. You don't need to create, right? Okay. So next what we have created the property. Next we need to create the material, right? So we can go to material. If you can see, I've already created two materials. So one is load 27 plus grit. So this will be for the glass, right? So I'll just expand it as you can see. Okay, and these are the values which I've used. Again, you can just go to my blog post, the link to which I'll give in the description, and you can just copy the values and just try it on, or you can take some other material, take some other values and try it on, right? Okay, so this material I've used for the windshield, the glass or the surface, whatever you want to call it, right? So after that, the next material which I have created is for the bird, right? I have named it bird only. So the values for this are as follows. Okay, as you can see. So again, the values for this will be in my blog post. You can just go and see that, right? So now we have the meshed model, right? And we have created the properties and the materials for both the components, right? And next, what we need to do, we need to assign this to the components, right? So we go to the component. Birds as well. If you can see, property ID is automatically created for the bird component, and material will assign here. Similarly, for the glass, we'll assign the property and the material, right? Okay, so this is done. So what is next? So next, we will create a contact. So what is the need of the contact? So contact is needed because the bird will go and collide with this surface, right? It's going to go and collide with this surface. So for that, we need to create a contact. So as you can see here on my screen, I've already created a contact, right? So you can create a contact by just right clicking on this white browser area in the solver browser. You can go to create, and then you can go to enter, and then you can go to type 7, right? And then you can select create the contact. So this is type 7 contact, right? Okay. So the values for this contact are as follows, and we have to select the master and the slave node, right? So I can just show you the preview of this, right? As you can see here, there's a master and the slave node, right? So you have to select the bird component and the class component or the surface component under the master and the slave, right? Okay, and these are the values as you can see here, right? So you can just, again, this is all given in my blog post, all the values, you can just go and check it out there, right? Okay, so we have this meshed model, we have the property, we have the material, we have the contacts. So what next? So next, we will give the boundary conditions, right? So what will the boundary conditions, if you see? So what will happen is, we'll keep this surface fixed in the space, and this bird will come at certain velocity and collide with the surface, right? So for that we need to assign the initial velocity to this bird, right? So if you can see here, I've already created initial velocity in well. Again, if you want to create this, you can again go to this wide browser area and just right click and go to create and then in well, and then you can select the initial velocity, right? So I've used the initial velocity of 550,000, right? As you can see on my screen here, right? And it's along the negative z direction, right? So, and I've assigned it to the bird component. If you can see, it's already highlighted, right? Fine. Okay. So next, we'll what we need to do, we need to fix the surface, right? For that, if you can see, I've created the boundary conditions here, right? PCs. So under that, I have the fixed, right? So in this, if you can see here, I fixed all the nodes, edge nodes of this surface of the windshield, whatever you call it. You can see I fixed everything, that all the translations and the rotation. Okay. So one more thing what I have done is I've created sets, right? You can see if you go to GR node here, I've created sets so that it becomes easy for me to select the nodes or the components which I want to restrict, right? So if you see, I've created a fixed set which contains all the nodes of this what you call the surface of the windshield, so that it becomes easy for me to select it here, right? Fine. Okay. So going back again, what all we have done? We have a mesh model, we have the property, we have the material, we have created the contacts, and now we have created the boundary conditions, right? Okay. So basically we are almost there. Everything is done apart from a small part. So this is Radioss, right? So what happens is we will give some uh, engine run parameters, right? The Radioss engine, when it runs, will give some parameters for its running. So for that, I have already created some cards here, as you can see under engine keyword. So there's one version, right? So version is basically it gives the version of the Radioss, right? Then we have the run, right? So inside engine run, we have to give the stop time, T stop. So I've given it as 0.08. You can try with some other time if you want the engine to run longer, right? For me, I've given zero point 0, right? So next will be the animation file, right? So you can just see here. So though I've used the anim dt card, I've given it the frequency value as 8 into 10 to the power minus 5, right? So then we have the animation vector card. For that, what all are there? I've selected okay, I've selected acceleration, displacement, p contact, contour, and all these things. So you can select others also if you want. It's just that the run might be a bit longer, okay, and might consume more resources, right? Then we have the engine and animation for elements, right? Here what we have, we have selected EPSP, I've selected energy, I've selected hourglass, and these things, right? So all these, what I have selected, you can get all the values on my blog post, the link to which is in the description, as I told before, right? So next, we have created the engine keywords, right? So what next? Should we run the solver? Well, we have created engine keywords, but we have not yet specified the output, right? So we are going to define an output for the contact. As you can see here, there are two outputs. One is for the contact, if you see here, right? Next is for the parts, right? Here I have selected two components. Here I have selected one group, right? Okay. So basically, to recap, we have a mesh model. We have made the property and material for them. We have created the contacts. Then we have created the boundary conditions, which includes the fixing of the surface and the initial velocity. Then we have created the engine cards, and then we have the output cards, right? So basically everything is in place. Okay. So what next? What next we need to do? So what we'll do is we'll just go to the solver. So for that we'll go to analysis. If you can see it here, right? And we'll just click it and we'll go to Radioss. You can see here, right? Okay. Export options will be all, run options will be analysis, and then we'll just click on Radioss. Okay. Okay. So once you click on Radioss, a pop-up window like this will open. Okay, right? And it will show you the remaining time and the time, right? And the last time here and the remaining time here. So if you can see, okay, so if you can see the remaining time, it's going up and it's again going down, and the last time it's showing here, right? So we'll give this some time to run. Post that, we'll see what the results are, right? So the run is complete now. So if you can see on my screen, so I have already opened the Hyperview window, right? So once the run is complete, we can just click on the results button as with other tutorials, and we can just go to the Hyperview window. Okay, so the window will look something like this, right? So if you can see my screen here, so we have different options here. We can use displacement, expression, contact, process, all the things we exported or requested for the output, right? So if you can see here, this is the surface, right? And these are the space particles. So we'll just play the animation, and if you can see on my screen, right? So you can see how the particles are going and colliding with the surface and then like dissociating, right? Now I'll just play the animation once again as in a slow motion right now. So as you can see, it's moving slowly, going, and it's colliding, right? Right, it's colliding as you can see here, and it's dissociating. So we can move on messages as well. If you want, right? We'll just click on apply and we'll just play the animation and we'll see. Yeah, so as you can see on my screen, so once it's colliding, so you can see how the stresses are developed, right? How the one message stresses are there, right? You can see these regions with green, blue, red, right? So basically, this is how we perform SPH analysis, right? Particles will be going and colliding with the stationary or moving component, and then they will go and dissociate, right? Okay. Okay, so this is all for this tutorial. Hope you understood the tutorial. Hope you got to learn something new, and hope this was helpful. So that's all for this video. So if you want more videos, more content like this, kindly subscribe to my channel, and you can also follow my Facebook and Instagram page. Okay, please like, share, and subscribe. See you all in the next video. Thank you.